In the last lesson of this unit, we are going to learn about inverse functions. Inverse functions are functions that cancel the original function, and that sentence probably sounds very confusing. But let's dig deeper into the concept of inverse functions. Let's understand what they are, and then we're going to learn how to calculate or how to find the inverse of a function. As we learned in the first lessons of this unit, these two number bubbles represent a function. Let's call it f of x, where we have an input and an output. Each one of these inputs has an output. 1 gives us an output of 2, an input of 2 gives us an output of 4, 3 gives us 6, 4 gives us 8. This is just an example of a function. The input, which sometimes we also call it the domain, is 1, 2, and 3 for this function. And the output, which is also called the range, is 2, 4, 6, and 8. So this is the information that we know from this function f of x. If we get the inverse of f of x, of f of -1 of x, the -1 on top means the inverse of the function. If we get the inverse, what's going to happen is, as the name says, we're going to invert this input and this output. So the number bubbles on the x and the y, they interchange of position. Now, the input of 2 gives us an output of 1, the input of 4 gives us an output of 2, 6 gives us 3, and 8 gives us 4. So we inverted the function. That's why it's called the inverse of a function. And of course, the domain and range also interchange their position. So this is what the inverse of a function is. Interchanges the input and the output of the original function. But let's analyze this a little bit further. We have the function f of x with these values, these coordinate points, -3 and 5, 0 and 2, 3 and -1. Remembering that the first number in the parentheses always represents the x coordinate, and the second number in the parentheses represents the y coordinate. Then we have f inverse of x, not f prime, f inverse of x. 5, -3, 2 and 0, -1 and 3. So let's see, the first x coordinate in f of x is -3. The second x coordinate is 0, and the third x coordinate is 3. The domain of f of x, we can say, is -3, 0, and 3. Those are all the x coordinates. But let's see how these numbers are related in the inverse function. The first x coordinate, as we said, it was -3. Well, but that's the same number as the first y coordinate of the inverse function. The second x coordinate in f of x is 0, which is the same as the second y coordinate in f inverse of x. And the third x coordinate, which is 3 in f of x, is the third y coordinate in f inverse of x. So the domain of f of x, -3, 0, and 3, is the same as the range of f inverse of x. So the domain and range interchange each other. Now let's analyze the y coordinates of f of x. We have 5 as the first y coordinate, 2 as the second y coordinate, -1 as the third y coordinate. So the range is 5, 2, and -1. But the first y coordinate, that's 5, is the same as the first x coordinate in f inverse of x. The second y coordinate, which is 2 in f of x, is the first x coordinate in f inverse of x. And the third y coordinate in f of x, or -1, is the third x coordinate in f inverse of x. So the range in f of x is the domain in f inverse of x. And this is an idea of how inverse functions are related with respect to the domain and range. But let's look at these inverse functions in a more graphical way. Let's say we have this function in the coordinate plane, the Cartesian plane, x and y. First of all, we have to make sure this is a function by using the vertical line test, as we learned in the first lessons of this unit. Just as many vertical lines as we can, and make sure each one of these vertical lines only crosses the graph once. So yes, good, it is a function. But then we have to, in order to get the inverse of a function, we have to make sure this is a one-to-one function. One-to-one function means, well, horizontal. Now we don't do vertical lines, we do horizontal lines. And we make sure that each one of these horizontal lines only crosses the function once, which is true for this one. So yes, it's an inverse function, and we can get an inverse function. It is a function. It's a one-to-one function. So yes, in few words, if we want to make sure we can get the inverse of a function, it has to pass the vertical line test and the horizontal line test. Now that we know this is actually a function and we can get the inverse of this function, let's get the inverse of this function. To do this, we need to make a dotted line, a diagonal line, the line y equals x, and all we have to do is a reflection of this graph about the line y equals x. So this purple, well, more magenta line is the inverse of the original function we had.